Let's actually run that code in Spark to find the degrees of separation between any two superheroes using breadth first search. Okay, let's actually find the degrees of separation between two given superheroes in our Marvel superhero dataset. So in the resources for this lecture, download the degrees of separation script into your Spark course folder. We're working up a pretty good library here of different examples here, so keep this around. You know, there's a good chance that some problem you face in the future will have a similar pattern to something we've already done here, and this might be a useful reference for you. Once you have that, double-click it. We already have the Marvel Graphs and Marvel Names text files for our input from previous lectures. And here it is. So again, the point here is just to illustrate how problems that may not seem like they lend themselves to Spark at first actually can be implemented in Spark with a little bit of creative thinking. And we also want to introduce the concept of accumulators here as we go. So let's look at our code here. We have the usual boilerplate stuff, nothing changed there. And we're going to define two character IDs that we're interested in. So we're going to say that we're going to be interested in degrees of separation from Spider-Man, who turns out to be character ID 5306. And what we're interested in finding out is how many degrees of separation is Adam 3031, whoever that is, to Spider-Man. And I intentionally picked some random character who I've never heard of because it's a little more interesting if it actually takes a few iterations to get through here to get a result. Now we talked about using a accumulator to signal to the driver script when we've actually found Adam 3031. So we're going to set up that accumulator that all of our different executors can use to signal once we've actually found that node that we're looking for. Okay, and we'll set an initial value of 0 on that accumulator and we'll call it hit counter. We covered the convert to BFS function in the previous lecture. So just to recap quickly, this sets up the initial conditions of our graph and converts our input data into node structures where each entry of our RDD is going to consist of a key value pair where the key is the superhero ID and the value is a composite value that consists of its list of connections, the distance, and the color. And initially, distances will be 9999 indicating infinity and the color of white, except for Spider-Man, who will be colored gray to start with a distance of 0 because Spider-Man is Spider-Man and gray indicates that we need to expand upon that node. Okay. Skipping down a bit to the meat of it, a lot of stuff going on here, but if we get down to the main program, we start off calling create starting RDD. Okay, let's see what that does. So what that does is load in our input file, the Marvel graph.txt, and then it's going to call the convert to BFS map function that we described just a minute ago and convert that into something that looks like node IDs. So nothing too complicated yet, we're just converting our input data into something that looks like nodes in a breadth first search traversal. Okay? What happens next? Now next we're going to go through some upper bound of iterations. So we're going to assume that we're never going to be more than 10 degrees of separation from anybody in this graph. If so, they're probably not connected at all. So we're just picking some arbitrary upper bound here. And we will iterate through the graph doing a BFS traversal up to 10 times. So the first time we'll say we're running BFS iteration number 1. And then we will call our flat map, which runs that first step that we talked about in the previous lecture of blowing out all the gray nodes. So that is calling our BFS map function. Let's see what that does. That's up here. And like we talked about, it just extracts the information from each node and looks for gray nodes and blows them out and colors them black, creates new gray nodes from their connections, and this is a flat map, so we're returning a results list of nodes that get added into the new resulting RDD. Finally, we put the original node back into the list as well so we can reconnect its connections back to that node in the reducer. So this creates, not only the original node we started with, but new nodes potentially that are colored gray that need to be expanded upon. And for each new node, we've incremented the distance to keep track of the degrees of separation. You're better served going back and looking at the previous 2 lectures if that doesn't make sense to you. It's a little bit more easy to understand graphically than by looking at the code, actually. And then next, we will call our... So to actually make that happen, we have to actually call an action. So remember, we have lazy evaluation in Spark. So just calling flat map doesn't actually make anything happen. And a very key thing happened in the BFS map function. So if we actually encountered the character that we were looking for, we incremented our hit counter, our accumulator, right? Very important point. So the moment that we encounter Adam 3031, this hit counter is going to get incremented, signaling back to our driver script that we have found the person we're looking for. But the problem is, map functions are transforms. They don't actually cause anything to actually get run in Spark until you call an action. So what we're doing here is a little bit of a cheat. We're calling the count function on that RDD to force it to get evaluated. And that way our accumulator will get set at this point. And it also prints out some interesting information as a side effect. We can see how we're actually processing more and more nodes as we expand outward from our starting node. If we did in fact encounter Adam 3031 upon that mapping pass, we will check that hit counter, see if it's greater than 0, and if so, print it out and say, hey, we found our guy. And we can actually print out how many times that hit counter was hit, because you can actually come at a given character from many different directions potentially. But if not, we'll keep on processing. So we will call the reduce by key function to actually gather together all of the nodes that we might have generated in that flat map operation and recombine them together for each given character ID, because there can be only one node per character ID, and that enforces that. So BFS reduce simply gathers them all back together, and it preserves the minimum distance and the darkest color found, and reconnects all the list of connections that were found for that original node. So if you want to stare at that code in a little bit more depth, you can get into the syntax of how it does that, but conceptually, that's what's going on. Okay, and that's it. Finally, we just keep on iterating through until we hit a maximum of 10 iterations, but nothing's going to get that high. So let's go ahead and run it and see what happens. Spark submit. Degrees of separation.py. All right, we're going through once, twice, still no Adam 3031. There he is. So on the third iteration through our breadth first search traversal, we finally found the guy we were looking for. He was only hit from one direction, so this guy is in fact pretty obscure. But our answer is Adam 3031, whoever the heck he is 3 degrees of separation from Spider-Man in our social graph. So there's your answer. And you can plug in different character IDs for anyone you want in here if you're curious and you want to play around with it. Also notice how we started blowing out to more and more nodes that we were looking at. So we started off with just 8,330 connections to Spider-Man himself, but we started looking at the connections of the connections, and we start getting into a very large number very quickly that we're processing on each iteration through. So you can see how these social graphs tend to branch out to a large number of people pretty quickly. And people really are a small number of degrees of separation from each other in many cases. And there you have it. Turns out the rumors are true. People really are connected pretty closely through various degrees of separation. Granted, this is a fictitious data set, but we had to pick a pretty obscure character to find someone who was even a little bit removed from Spider-Man, for example. And if you were to try to do this between any two well-known superheroes, they're probably just connected by 1 degree. So there is truth to this whole degrees of separation thing. It's not just a made-up thing. But I digress. The whole point was to illustrate how to do a more complex algorithm like breadth first search using Spark. So you're not limited to just doing simple mapping and reducing functions with Spark. With a little creativity, you can take more complicated problems like this and frame them as Spark problems. And that's really the skill that they're going to pay you the big bucks for. So the more you can think about how to frame problems as distributed Spark problems, the more valuable you'll be as a data miner.